At first, we want to start with what is machine learning about, the principle of machine learning, the concept of machine learning. So this is a process of training the algorithm, okay? The process of training the algorithm using our historical data, okay? For example, you have your spreadsheet, and then you already identify what are the things that you want to want to predict, okay, and then you want to create a model that able to predict that particular event ataupun output, okay. So actually the process is you have the historical data, and then you train the machine learning algorithm, okay, you train the algorithm, and then at the end of the day you will produce the model. That is the things that we want to achieve, okay, the outcome of the machine learning process. Okay, you want to have a predictive model, okay, you want to have a predictive model so that you can use that model to predict the future outcome. Okay, so try to imagine, this is a two phenomena that I want to show with you the differences between conventional processing and also the processing or using a machine learning. Okay, in conventional processing, take a look into the example here. If let's say I want to log into my email address, okay, I have to input my password, and then I have to input my username at first, and then if that is correct, then I have to input my password. Okay, so you see this kind of situation has been predefined by the programmer. So the predefined, what is meant by predefined? So I have to, okay, at the first, when I register, okay, when I have to register my email address, okay, so what I have to do is I have to I have to create my account using my username, and then I have to define my password. Right. Okay, so that are the things that we have to do. So you see here in the flowchart here, okay, everything is already been predefined. Okay, so this is okay for a very, what we call for a very specific kind of situation, okay, that require for individual assessment. Okay, for example, for me, this is a condition for me to enter my password. For you, might be a different password. Okay, but when it comes to another bigger problem, okay, for example, we want to understand the trend. We want to understand the irregularity of the data. Okay, so we cannot rely on this anymore. Okay, the things can become sophisticated. Okay, so of course, if let's say, okay, for example, I want to do the transaction, right? I want to do the transaction. Okay, so there is some part of the transaction already been predefined. For example, if let's say, okay, my transaction limit is 5,000, for example. So every time I make a transaction, so the amount, the maximum amount is 5,000. So that is predefined function. But when it comes to the problem related, or let's say if I want to transfer more than 5,000, okay, 10,000, for example. So I cannot transfer that because my system already defined that I can only transfer 5,000. Okay, but how about in a fraud cases? Okay, dalam fraud punya case. So in fraud cases, okay, you see that the situation here something like, okay, for example, I didn't have any condition of transferring money, okay, but the way I do the transaction process, okay, I never send money, okay, I never send money, I never do the transaction. Usually the average transaction that I make maximum is maybe 10,000 per transaction. Okay, suddenly, okay, the system detect that I transfer maybe 100,000 once in the transaction. Maybe my activity that time, every day I do the transaction on the money. Okay, that might be cases where fraudulent can happen. Okay, and that is not predefined by me. but that is detected by the algorithm that try to understand my purchasing behavior. So in here, in this case, we need, okay, the historical information about my transactional activities and try to match with what actually already happened. Okay, what actually already happened. So today we are going to do some small example on the transaction later on. So as we will understand, okay, we will understand whether how's the fraud cases happen. Okay, we are going to use the bank data set, okay, in the afternoon session, I guess. Okay, all right. So you see here the ML model will define, the model itself will define whether that transaction is fraud or not. Okay, but of course there is probability involved here. So machine learning is using the knowledge of probability and statistic. Yeah. Okay, not, for example, if let's say the transaction is legit, sometimes you can see that the confidence level, okay, the confidence level of to define the transaction legit or fraud, they must be a certain percentage there. 70%, then that transaction is a legit transaction. Okay, if let's say the threshold that we set is 50% that the transaction is legit, then maybe it's not legit transaction. We can put the threshold there. So any threshold that gives the probability more than, for example, 80%, okay, threshold, then that is a legit. So it means that that is the things that is the threshold is defined by us. Okay, the threshold is defined by us. Okay, all right. So the machine learning can be used for forecasting, yeah, the price of the stock market, the price of the house. Okay, later we will show some example there. Okay, and for example, you want to predict whether the people will buy or not buy. Okay, if they come to your store. Okay, whether the customer will churn or stay if they subscribe to your bank services. Okay, and also fraud detection, as I mentioned earlier. Okay, optimization process, optimization. Okay, you want to find the coefficient of the features that you use to predict the output. Later on, we will understand what is the output input in the machine learning. Yeah? Okay. Another one is recommendation system. This is more likely an advanced mode of machine learning. Okay, this is towards AI application. Okay, so there are a few level. Mostly, I can define as a 3 level. Okay, the conventional machine learning, the one that we learned today. If you want to go more smarter model, okay, you can use a recommendation system, which is towards AI, and then another one is deep learning. Okay, that is a more advanced version of the most advanced version of machine learning. Okay, if you go to the deep learning, yeah. Okay. All right. So you realize that when we watch Netflix, for example, okay, so most of the movies, okay, most of the things that we watch is based on recommendation, based on what we have, our historical behavior before. And our behavior is actually predicted by the others' behavior. Okay, for example, okay, there's a lot of data set already understand that most people that watch Thor and Iron Man movies, they will watch Avengers, for example. Okay, so if let's say suddenly I watch Iron Man and Thor, probably I also want to watch Avengers. Okay, so my behavior is predicted based on other user behavior. Okay, so these are the model that been created by the other users and then apply it to me. Okay, so these are the things, how the things work. Okay, all right. So there are 3 types of machine learning. Okay, so the first one is supervised learning. Okay, so in supervised learning, our samples or data set, they have, we call as a label. Okay, we call as a label, output label. Okay, so what does it mean? So for example, these are what we call as input, could be an input. Okay, the candidate as an input variables. Okay, which can be used to predict the price of the car. Okay, so this is the label. We know what we want to predict. Okay, so the problem is like a structured problem. Okay, so the problem is supervised. So when you create the machine learning, it already been supervised by this level. So you know already your target output. Okay, but in some situation, we don't know. Okay, we don't have any valid label or any output label. Okay, so I only have, for example, in this case, I have satisfaction and loyalty, okay, in my table data set. Okay, so it means if I'm satisfied, doesn't have, my loyalty might not be, I might not be loyal to the company, to the services. I might loyal, but maybe I'm not satisfied. So we cannot find any mutual relationship between these two things. Okay, but when we plot the graph, we can identify some trend, some cluster. Okay, so that we can define the behavior of our customer. Okay, so satisfaction cannot be used to predict the loyalty, and loyalty also cannot be used to predict the satisfaction. So in this case, we don't have any level of output. Okay, both of them are features. Okay, so we have to know first. If let's say from here we cannot find any output, so then what actually we want to do? So most of these unsupervised problem already been, sometimes when you come to the data collection, for example, okay, so you have to design properly your data collection. Okay, so usually the unsupervised problem, we don't collect data randomly. Okay, what I mean is, what the age, what it is. No, we have to understand the kind of cluster or the what kind of behavior we have to understand first. So at the end of this session, later on, we will try to understand how do we do that. Okay, in cluster problem. Okay, so another one is a reinforcement learning. Okay, this is more towards the AI application. Okay, where we want that system to be more intelligent. Okay, because most of the problem that we experience when we want to predict something, it's not a linear problem. Okay, it could be a non-linear problem, which is very hard to prescribe using a linear model. Okay, so we have to use this kind of reinforcement learning method. So you see both of these, supervised and unsupervised learning, to ensure that we have a good quality of the model. Okay, so we have to measure, okay, the number of measure the algorithm try to minimize the error. The lesser the error that we have, okay, the better the model. Okay, but in reinforcement learning, we apply a reward system. Okay, we apply the reward system in order to minimize the loss, okay, by maximizing the objective function. Okay, we want to maximize the objective function. Okay, for example, okay, in our daily life, for example, okay, during our school time or whatever is it, okay, when we make a correct answer to the question that been described by our teachers, for example, okay, if let's say I answer it correctly, then I can get the, for example, the rewards. Okay, and that rewards can make me more understand. Okay, so that how to say, the rewards will keep reminding me. If let's say in the future there will be a question like this, so I can answer it. The answer is like this. Okay, but if it is wrong, so I will receive the feedback. You have the wrong answer. So my model will be continuously improved, okay, by maximizing. Okay, so wait, right. Okay, so there are two models that we always talk. If we go to neural network, we have conventional neural networks and we have more deeper neural networks. Okay, and even we have convolutional neural networks. Okay, so but if you want to go to this to learn about neural network, you have to understand first the machine learning concept. Then you can go towards it. Okay, all right. So if you ask me, is it easy or difficult? If I want to go deeper, it's not that difficult. Okay, it's not that difficult. Okay, because in Python, everything already has packages, but we have to understand the concept and then how to make it into a code. So that is the most important. And the way we analyze, the way we study on the how good is the model might be different. The indicator that we use, okay, might be different. Okay. Okay, so another way to describe the machine learning is by this model, okay, by its model. Okay, it could be, okay, in supervised learning, okay, we have some sort of algorithm that already been grouped under a supervised learning. This is some of them, okay, there are a lot more. Okay, for example, if supervised learning, we can use linear regression if our problem is regression problem. Okay, unsupervised learning, k-mean clustering, if you want to clustering the model, a priori algorithm, let's say we want to do the recommendation system, okay, and go for reinforcement learning is neural networks. Okay, so the most simplest one that we can find, as you can see here, is the straight linear model. Okay, all right, so this is general flow. Okay, before that, okay, is there any question before I go further? Is it okay? Any question? Ada soalan? Tak ada. No. So far, okay, good. Am I too fast? So far? Okay, all right. Thanks, Norismi. Yeah. Okay, so far good, Okay. So if you have any question, just ask me, and then okay, the things that I can ask, okay, I can answer, then I will answer. Okay, something that might be more advanced, maybe out of my field, so maybe I need to do some research on that. Okay, but most of the question I try to entertain lah. Okay, based on my understanding and based on my experience. Okay, all right. So the first, okay, if you want to start with machine learning, how do I start? Okay, so I provide the general step here. Okay, if you go Google and everything, so there are a lot of steps there. So this is the way I define my steps. Okay, the way I define in general process. Later on, we can go for more sophisticated model. So the first is to understand the requirement. Okay, if let's say you works, if let's say next in the future you works for the maybe yourself as a consultant, okay, data science consultant. So one part of your project is to do a prediction model. Okay, so the tips is to understand the requirement first. Okay, some clients sometimes they just give you data and then what we can do for, but without we understand the problem, that might be a very difficult situation. Okay, there are two things based on our experience. Based on our experience, there are two scenarios when you do the consulting works. Okay, first is, okay, they just give you the data set and then you try to come up with the idea. That kind of things might be very, how to say, sometimes you do the works that already been done. Okay, so we want to avoid that. Okay, another situation is they have the problem. Okay, they define the problem to you. Okay, this is our problem. Okay, but they don't want to give you data. So how do we work? Sometimes they say, oh, this data. Are we going to do the data collection ourselves? Okay, so that might be things that you have to explain, yeah, engage with your clients in the future. Okay, so okay, let's back to this situation. So you have to understand the requirement first, okay, and then you gather the data from them. So that's the first thing that we do. Okay, and then of course, during we understand the requirement, and then we have to do the analysis on the data. Okay, later on we will go more deeper. Okay, for example, we do the feature engineering. Okay, and then we select the right algorithm to build our machine learning model. Okay, so after that, after I have this algorithm, then I will train that algorithm based on the data set that I already created. Okay, so that data set, the historical information, okay, about the record activities, about what actually happens. Okay, so and then after I train, okay, then I evaluate the performance of the model. Okay, so if this is okay, then I can save and use that model for production, for for the implementation. Okay, if it is not okay, so you have to adjust the parameters. Okay, maybe you can change a new algorithm. Okay, tukar algorithm, to guna algorithm yang lain. Okay, so these are the generic steps. Okay, how to achieve how to do machine learning works. Okay, if we go more deeper, okay, okay, I can describe. Okay, most of my works are dealing with something like this. Of course, there will be a lot of features, a lot of steps, okay, that might be hidden somewhere here, hidden somewhere here. Okay, so but for me, I always start with this. Of course, you need to call the data from repository into your repository, perform the exploration to knows whether the data is clean or not, okay, whether it's duplicated values or not, okay. And then the third one, you have to understand, if there is a problem in the data, do the cleaning first, okay, treat that data, okay, and after the data ready for the production, not production, but already at a stage, it's good enough, then you go for data preprocessing. Okay, another words for data preprocessing is we call as a feature engineering. Okay, feature engineering, because we want to deal with the feature. What is a feature? Feature is actually the inputs variables. Okay, features is a input variable. Later I will cover on that. So what we do first, we have to do the test. Which feature that affecting the output? Okay, for example, this is more likely into a supervised problem. Okay, supervised problem. Okay, for unsupervised, later on we will see. Okay, the way we do, actually the process is almost similar, but some steps might not necessary in unsupervised learning. Okay, and then we have to handle if there is any categorical variable, and then we have to define where is our input, where is our output. Okay, and then we have to do the scaling. So we will also do the scaling in our example later on. Okay, and then we have to partition our data into train and test. Okay, we use the train sample to train our algorithm. Okay, and we use test sample to evaluate the performance of our model. Okay, so and then we analyze the performance. So there is a one tips that I want to mention here. Yeah? So if let's say we do our work, usually we don't rely only one indicator. Okay, to confirm, to evaluate the performance of our model, sometimes we need minimum two indicators. Okay, one is okay, but it depends on the problem. But usually I use two. For example, in supervised model. Okay, so the performance metric that I measure first, maybe using the standard metrics. The second one is I will compare with another approach. Okay, which is more likely analytical method. Okay, we compare it. Okay, so I will teach you also in that method how to evaluate the performance using two indicators to confirm that my data is correct, the model is good or not. Okay, all right, so what do you need, okay, to do the machine learning? Of course, first you need data. Okay, you need the historical data. Okay, and this data could be have a problem, might be. Okay, second, you need to have the mathematical model. Okay, the algorithm, the model that you are going to train. Okay, that you are going to train using your historical data. Okay, and we need the programming tools. Okay, to automate the computation process. Okay, using a standard, pre-installed libraries in your system. Okay, so everything, these are the things that make easy for our works compared to conventional way, okay, of defining the model, to train the model. Okay, so we have programming. So that's why today class, we are going to use the programming knowledge for our works. Okay, programming knowledge in our works. Okay, so I believe everyone already familiar with iLog. Okay, so today we are going to apply that. Okay, by the way, I will teach you lah. So there are a lot of ways to do it actually. Okay, to sometimes what I'm teaching is based on what based on our experience to do our works. If you're Googling on the internet, there might be another one, but the approach, the process might be as similar, okay, might be a similar steps, okay, but of course for us we based on our experience, okay, some steps might necessary, some steps maybe no need, yeah, okay. So there are a lot of application. This is just some part of it, okay. If you go broad, so there are a lot, okay, healthcare, okay, in there are lots, okay. So for example in finance right now, okay, it's in image processing, so this go is more like deep learning, computational biology, yeah, energy production, manufacturing, and even natural language processing. Okay, so the most interesting works if you go advanced, for us we call as more brain excitement, yeah, brain excitement project is related with, first is image processing, second one is natural language processing. This is the things that really give us a challenge, okay, to test our limits, okay, and to another stage, okay, because sometimes even we have solved one problem, but when we go to another problem related with natural language, could be a different sets of technique that we have to apply. So this is totally, these two things are totally brain challenging machine learning activities, okay, all right. Okay, so in Python, so there are two packages, okay, that we are going to learn today. The first one is the stats model. The second one is the scikit-learn, okay. This is the specific packages for machine learning, okay. So there might be other packages, but this is the most popular one, okay. So the stats model, I will teach you how to use this for a regression problem. And the scikit-learn, I will teach you how to use these packages for classification and clustering problem, okay. So later on I will show to you why stats model is very good for regression problem, okay.